Hello and welcome. Today we're going to be talking about trigonometric identities that involves products, and we're going to rewrite them as if they are sums and differences. Before you get into this lesson, you need to understand one, the sum and difference of angle formula for trig functions, okay, and also double angle formula is worthwhile having underneath you so that you can approach this with a bit of confidence. Okay. Now, basically, the idea of this particular lesson today is to go and relate this idea of multiplication of trig functions into something that we already know, which is the sum and difference angle formula that we've seen before. We know that we can go and expand each of these particular things inside of the trig functions there, okay? So what we want to do is we want to take something that's a little bit different, okay, and rewrite them with something that we know. So there's nothing new here today in terms of concepts. It's everything that we already know. We're just repackaging it. Now, these are on your HSC reference sheet. Okay, you can find them on the second page on the bottom left underneath the compound angles heading. They're very, very, very useful. They get given to you. But because there are other different ways of approaching the questions that are usually asked with this, these particular formula often get forgotten, despite having a common application in HSC questions. If you can remember these formula, it's often, or formulae, I should say, it's often easier to go and approach these types of questions um, rather than the stock standard sum and difference and double angle formula ways. Okay, so basically, this lesson is all about building efficiency and having a bit of a play so that you can go and use them. So it's worthwhile to go and practice these particular skills and not just sort of toss them out the window. Okay, all right. So our first video today is going to focus pretty much entirely on proving each of these four results. Our second, and possibly a third, but most likely just a second video is going to focus on using them in different types of both basic questions and more complicated questions, all the way up to a HSC style of question that you may encounter. Okay, all right. So let's dive in and let's have a little bit of a look at proving each of these particular results. Something that is worthwhile before we do that, though, is noticing that when the two trig functions on the multiplication side of the equation are the same, so for example, cos and cos and sine and sine, inside of the inside of the big brackets, they are both cos functions, and when they are different, okay, you'll notice that they are both sine functions. Okay. All right, let's jump into it and have a little bit of a play with the proof. Okay, so we're going to prove each of these in turn. Okay, the way that this proof works to try and approach it is slightly different to how you may have seen some of these things before. But essentially, what we are going to do is instead of using either a left-hand side or the entirety of the right-hand side, I'm actually going to use just a part of the right-hand side that we know to go and work with. You don't have to do it this way. I just think it's nice for you to see the development from earlier skills that we have. Okay, so let's have a little bit of a play. I'm going to start with the inside of the brackets and state that we are, let me write this in a more permanent pen, we are given cos of A plus B. Not so much that we're given, I might restart that particular style of proof. We know that cos of A plus B plus cos of A minus B is equal to, and using our sum and difference formula, okay, it is equal to cos A times cos B minus sine A times sine B. Okay, and I'm just going to underline that's our first particular statement there. All right. And then for our second particular statement over here, it's going to be adding on for the green. I'll do this in two slightly different things. It's going to be cos A cos B plus sine A times sine B. Now I might just bring this back over so we have absolutely everything on the screen. It's not going to be perfectly aligned, but I'll bring it down a slight level. Okay, so we can keep everything together. And what we're paying attention to here is where it's a plus inside of the cos bracket, it's a minus outside. Okay, and where it's a minus on the inside, it's a plus on the outside. Okay, right? You might notice something straight away has occurred, and you might be able to see that there is a common element in both of these. The first one being that we have cos A, cos B plus itself, so we'll have two lots of that. But we also have a minus sine A, and I'll highlight this here, plus sine A, sine B. Okay, so they are actually going to cancel off and leave us with just this expression. 2 cos A cos B. So now we have this particular expression that's going to pop out for us that we've just went and created. Okay. That's essentially the result that we've just went and established using our sum and difference angle formula that we know and love, that we're familiar with. And now you'll notice what we want to end up with looking at our proof is we want the cos A and cos B to be by itself. Okay, so what I'm going to do is I'm going to divide by this 2 to the other side, and you might already be seeing this result sort of occur. Okay, dividing by that 2, we now have cos A cos B is equal to 1/2. That's the same as me multiplying by a half. Okay, outside of cos A plus B plus cos A minus B. Okay, which is something that we've sort of seen before. We've now established the result, okay, which is exactly what we're after. Okay, so we've finished the proof. We've proven that the left-hand side is now equal to the right-hand side. Okay, so left-hand side equals right-hand side, and we are done finishing off our proof with a box or a tombstone, whatever you would like to call it. Okay, moving on to the next one. Now we're going to have a little bit of a look at the sine, where they're both sine functions being multiplied together. Again, very, very similar to what we're going to do. We're going to focus quite heavily on the internals of this particular bracket here. Okay, we're going to unpack that and we're going to unpack that. Noticing that it is cos A minus B and then it is cos A plus B. Okay, so looking at the first set of the internals. Okay, so we know that cos A minus B minus cos A plus B is equal to. Now I'm going to expand, and I should have done this particular one up here in blue so we can keep track of our working as we go along. Okay, so we know looking at that first set of brackets and expanding it out, that first one is equal to cos A cos B plus sine A sine B, and this is just using our sum and difference of angle formula. I'm going to put a minus, and now I'll switch to blue, and I'm going to put brackets around this so that I don't make any mistakes with any negatives that are going to come in later on, just because I have that negative right there, okay, and it could play a little trick on me a little bit later on if I'm not being careful. So now looking at this particular bracket, it's equal to cos A cos B, subtract, because it is a plus inside of the bracket, subtract sine A times sine B. Okay, and now I'm going to close that bracket off nice and clearly so we can see what's happening. Okay, now unpacking all of this again, I can expand that bracket out so you can see what will happen. So I'll do that for us. So this is now equal to cos A cos B plus sine A sine B minus cos A cos B plus, being very careful with this double negative occurring inside of that bracket, sine A sine B. Okay, alrighty. Now, doing our cancellation again, you'll notice that I have a cos A cos B minus another cos A cos B, and I have two lots. Okay, unpacking that, two lots of sine A times sine B. So a very similar style of proof as to what we had before. So we've just established this result, 2 sine A times sine B is equal to cos of A minus B minus cos of A plus B. And just like before, we want the left-hand side to only have two trig functions multiplying each other. Okay, I'm going to multiply both sides by a half, or divide the other side by 2, however you want to phrase it. and we're going to have exactly what we were after from our original statement that we were required to go and prove. Okay, so we've proven that the left-hand side is equal to the right-hand side, and then Bob's your uncle. Okay, alrighty. So now we're going to have another go at the other two particular statements that we need to go and prove. I might invite you to pause here and have a little bit of a go yourself, just so you can get a little bit of a feel for what's going on in terms of the style of proof. It is very much a similar structure, but just bearing in mind that we're using a slightly different sum and difference identity, because now we'll be working with sign functions inside of that bracket to start us off. Okay, alrighty. If you want to have a go, go for it. If not, stick with me. So, looking inside of the bracket, we have sine of a plus b, okay, and we're adding that along with sine of a minus b, okay? So, right, let's unpick our particular knowledge that we have with that. So we know that sine of a plus b plus sine of a minus b is equal to, doing the sine of a plus b, okay, is sine a, and this is where it gets a little bit different, times cos b, remembering our sum and difference angle results, okay, plus, switching now the letters and the trig functions, cos a times sine b, and that's our first bracket, or our first trig function done up inside of that bracket. Now going for our second one, so plus sine a cos B minus cos A sine B. Keeping in mind the things that we want to pay attention here. One, we don't have both of the same trig functions in the expansion. Okay, right? So you noticed before it was cos A cos B. Well, now it's sine A cos B. And the other thing that you'll notice in relation to this particular thing is the fact that I have a plus here and I have a plus between the two lots of the trigonometric terms. Same thing here, being a minus here. I also have a minus here between those trigonometric terms. Now, moving on, you might notice something really convenient. We have two sine A cos B's. However, we have a cos A sine B subtracting off with another cos A sine B. So again, that exact same structure of proof, okay, that we've done before, but this time now we're resulting in two sine A cos B's. Nothing changes from this particular point, okay? We've just established 2 sine A cos B is equal to sine A plus sine, oops, sorry, let me just restart that again. Sine of A plus B plus sine of A minus B. Okay, having a little bit of a play around with absolutely everything going on, we want to isolate to go and get the two sine functions that are being multiplied together by themselves. So we're going to multiply both sides by half. So we end up with sine A times cos B is equal to 1/2 sine of A plus B plus sine of A minus B, closing that big bracket. So we now have the left-hand side is equal to the right-hand side as we required, and we finished off our proof. Okay, the final one now, okay, that we are after, I'm just going to get rid of our earlier proof there. Okay, the final one that we're after now is now cos A times sine B is equal to 1/2 sine of A plus B minus sine of A minus B. I'm going to invite you to do this one by yourselves. I won't cover this inside of the video, as I think it's a worthwhile exercise for you to have a little bit of a play with. Okay, and it follows the exact same structure, so it's useful for you to develop the habits around the thinking and the writing out of the proof yourself. Okay, so in this particular video, what we've done is we've gone through and we've proven that these particular four results work. We've seen where they come from, so we're using our existing knowledge to sort of build upon and just sort of reframe. Okay, in the next video, we're going to use these four formulae to go and approach different styles of questions. Okay, thank you very much. I'll see you there.